Good morning, students. New chapter, chapter number 7, systems of particles and rotational motion. Yes. In previous lectures, that is chapter number 3, chapter number 4, 5 and 6, we have discussed about motion of object, okay, of some particle, of some object. Okay, now in this chapter we study system of particles. Okay, in previous chapters we have discussed about objects. Okay, one car is moving, one stone is falling freely, one person is moving. Okay, now when you are given particles and their distribution, then what is system of particles, their behavior, their motion, their velocities, their acceleration, forces acting on them, and then next portion is rotational motion. And yes, this chapter is important chapter. Okay, so yes, we will start system of particles with first definition, that is center of mass. Center of mass. Now what is center of mass? It is a point of object or a system. It is a point of object or system where whole mass of object or system is said to be concentrated. Okay, a point where whole mass of system is said to be concentrated. Okay, it is also called mass weighted average position of system. Mass weighted average position of system. Okay, so yes, first topic that we will discuss in this chapter is center of mass, a point where whole mass of system is said to be concentrated. Mass weighted average position of system. It depends on shape, that is geometry of object, okay, and mass distribution. Okay, it depends on shape, mass distribution. Okay, now if I'm taking some examples. For example, if I have one square plate like this, okay, and yes, mass is uniformly distributed everywhere. Then yes, its center of mass, it is as its geometrical center, that is here. It is center of mass. If I have one ring, or it is one disc, okay, then for this disc, as it is symmetrical object, its center of mass is here at its geometrical center. Clear about this? So yes, what is center of mass? Center of mass means a point where whole mass of system is said to be concentrated. Mass weighted average position of system. It depends on shape. Okay, shape means we can also write its geometry. And mass distribution. Clear about this? So yes, it is center of mass. Now we have to find center of mass for different particles distribution. For example, if you are given two particles, then where is center of mass for that system? If you are given three particles, then where is center of mass? If you are given numbers of particles, then where is center of mass? If you are given one square plate, then where is center of mass? One disc, where is center of mass? Okay, one object having irregular shape, then where is its center of mass? That we have to calculate now. Okay, so yes, now we will see center of mass for various distribution. Okay, and in this case, first theory is first theory is center of mass of particles in one dimension. Center of mass of system of particles in one dimension. Okay? Yes, what is title? Center of mass of system of particles in one dimension. Okay? So now where is center of mass for this system? That we will see. For that, I am assuming first case 1. Okay, yes, I have two particles having masses m1 and m2. Okay, for example, as it is one dimension, that it is origin, it is x-axis. Okay, it is origin. First particle is here having mass m1. Another particle is here having mass m2. Okay, like position of first particle from origin is x1, position of second particle from origin is x2. Simple. So yes, we have two particles having masses m1 and m2 and at position x1 and x2 from origin. So let two particles having masses m1 and m2 are placed at positions x1 and x2 from origin O. Simple? Yes. These two masses having masses m1 and m2, they are placed at position x1 and x2 from origin. So where is center of mass of this system? Yes, center of mass means it is a point where whole mass of system is said to be concentrated. So yes, I am assuming that center of mass of the system is here, not exactly between them. Okay, that it is here. That center of mass is here at distance x from origin. Okay, so yes, what is x? X is mass weighted average positions of x1 and x2 and is given by and yes, I will write this x as x center of mass. Therefore x center of mass is equal to it is m1 x1 plus m2 x2 divided by, here it is m1 plus m2. Clear? So yes, this equation you have to remember. If two particles having masses m1 and m2 are placed at positions x1 and x2 in one dimension, then their center of mass is a point whose position is x center of mass is equal to m1 x1 plus m2 x2 upon m1 plus m2. Clear? Okay, so yes, this equation you have to remember. Okay, where x center of mass, it is position. X center of mass is position of center of mass of system. Clear about this? So yes, if we have two particles, then center of mass for these two particles, how to calculate it is easy with the help of this equation. Okay, now we will see some special cases for two particles. See some special cases. First, if m1 is equal to m2, If these two particles have same mass, if these two particles have same mass, then what happens? You have to put values in this equation. Okay, so yes, x center of mass is equal to m x1 plus m x2 upon 2m. Okay, now m common, so yes, it is m x1 plus x2 divided by 2m, m anchor. Okay, so therefore x center of mass is equal to, it is x1 plus x2 divided by 2. It is x1 plus x2 divided by 2. Simple? Yes or no? Yes, this is. Okay, x center of mass is equal to this x1 plus x2. Okay, what is meaning of this? Meaning of this is, if I have one particle of mass and here another particle of mass and here, then their center of mass is at its middle point. Center of mass is at midpoint, as at its midpoint. Simple? Okay, so yes, you have to remember this point. If you are given two particles or two objects having same mass, then their center of mass lies exactly at the midpoint on the line joining two particles. Simple? Okay, now we will take another two cases. For example, case 2. For example, case 2. See, in this case, I am taking x1 and x2 common. I am taking x1 and x2 common. For example, x1 is equal to 10 meter and x2 is equal to 20 meter. x1 is equal to 10 meter and x2 is equal to, it is 20 meter. Yes or no? Yes, it is. Yes, it is. So see, if with the help of this equation, you find what is center of mass, that it will be at 10 plus 20, that is 30 divided by 2 means 15, which is exactly at that midpoint. But now I am taking another two cases. See, if m1 is greater than m2, m1 is greater than m2, m1 is greater than m2, and I am assuming values m1 is equal to 20 kg and m2 is equal to 10 kg. Then what is x center of mass? So yes, x center of mass is equal to, x center of mass is equal to, it is, what happens? CH center of mass is equal to m1 x1, m1 x1 plus m2 x2. What is m1? 20. What is x1? 10 plus m2 10. What is x2? 20 divided by m1 plus m2, means it is 20 plus 10. Simple? Means it is 20 plus 10 is equal to, it is 200 plus, it is 200 divided by, it is 30, divided by, it is 30. So is equal to, it is 400 divided by 30, it is 0 0, it is 0 0, means it is 40 divided by 3, it is 40 divided by 3. So yes, your answer is nearly 13.3 something. Okay? Because 40 divided by 3, 13 into 3, 13 into 3, yes, it is 39, so it is nearly 13 point something. Clear about this? Okay, yes, 13 point something. See, it is 10, it is 20, so it is, if 15, then 13, it is near to m1, it is near to m1. Now we will see another case. See, then you will easily understand. If m2 is greater than m1, means m1 is equal to 10 kg and m2 is equal to 20 kg and m2 is equal to, it is 20 kg. Then what happens in x center of mass? X center of mass is equal to, x center of mass is equal to, it is, here it is m1. What is m1? 10. What is x1? 10. m2 20. Here it is also 20. Then it is 10 plus 20 is equal to 100 plus 400 divided by, it is 30 is equal to, is 500 divided by 30, so it is 50 divided by, it is 50 divided by 3. So see what happens in these two cases. What happens in these two cases? Okay, so see, in first case your answer is m1 is greater than m2. then it is 13.3 meter, while in second case 50 divided by 3, 50 divided by 3, it is nearly 16.6 meter. It is nearly 16.6 meter. So see, what is meaning of this? What is meaning of this? If two particles having same mass, then their center of mass is exactly at that midpoint. Exactly at that midpoint. If m1 is greater than m2, yes, it is 15 centimeter. It is 15 meter. If m1 is greater than m2, then center of mass it is at 13.3. Means this side. Means yes, this side. Yes or no? Means see, center of mass is near to particle having large mass. Okay? Or center of mass is near to heavy particle. Center of mass is near to heavy particle. In this case also, m2 greater than m1, then see, center of mass is this at 16.6 meter, means at about this side. Okay, then yes, what is conclusion? Conclusion is center of mass is near to heavy particle. Center of mass is near to heavy particle. Center of mass is near to heavy particle. Is near to heavy particle. Clear about this? So yes, this point you have to remember. Now this theory is for two particles, m1 and m2. If you are given numbers of particles, okay, m1, m2, m3, m4, dash, 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 then what is equation for center of mass? That we will see. Now, if we have more than two particles, okay, let for n particles, okay, then what is equation to find center of mass? Then position of center of mass, x center of mass is equal to m1 x1 plus m2 x2 plus x2 plus so on mn xn divided by m1 plus m2 plus or minus plus n raised to m. Okay, so it is one general equation for system of n particles, but for n particles in one dimension, okay. Now if you are given particles in 2 dimension or 3 dimension, then how to find center of mass? So yes, next title is center of mass of system of particles in 2 or 3 dimension. Okay, and for that, yes, we are assuming one figure, and let it is x-axis, y-axis, it is z-axis, it is origin, and we have particles like this. It is first particle having mass m1, another particle having mass m2, another particle having mass m3, numbers of particle are there. It is nth particle having mass mn. Okay, and their position vectors are respectively. Position vector of first particle is r1. Position vector of second particle is r2. Position vector of third particle is r3. Position vector of nth particle is r. Clear about this? So yes, we have n particles. Their masses are respectively m1, m2, m3 dash 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 mn, and their position vectors with respect to origin are r1, r2, r3 dash 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 r. Okay. So yes, as shown in figure. particles having masses m1, m2, m3 dash 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 mn have position vector r1, r2, r3 dash 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 rn dash 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 rn with respect to this point O. Clear? Then yes, for this system of particles, there is one point. For this system of particles, there is one point where whole mass is to be concentrated, and it is called center of mass. So let it is center of mass having position vector r center of mass. Let it is center of mass having position vector r center of mass. Clear about this? So yes, let position vector of center of mass of system is r center of mass. Then how to write equation of r center of mass? R center of mass is equal to m1 r1 plus m2 r2 plus m3 r3 plus so on mn rn, and divided by it is m1 plus m2 plus m3 raised to mn. Clear about this? So yes, what is difference in equation? See, here it is. For one dimension, you have to write only position, means distance from origin. While in case of 2 dimension or 3 dimension, you have to write position vector, that is r1, r2, r3 dash dash dash. Okay, so it is difference between these two equations. Okay, now here m1 plus m2 plus m3 raised to mn is equal to what? Capital M. That is mass of system. Total mass of system. Clear about this? Yes. This particle first having mass m1, m2, m3 dash 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 mn. So if I add their mass, it is called mass of system. It is called total mass of system. So yes, I can write this equation as r center of mass is equal to it is m1 r1 plus m2 r2 plus m3 r3 raised to mn rn, and divided by it is m. So now I can multiply this and this side, means it is m. R center of mass is equal to m1 r1 plus m2 r2 plus m3 r3 plus s2 plus so on mn. Clear about this? Now what is meaning of this equation? See, what is center of mass? It is a point where whole mass of system is to be concentrated. Whole mass means m, and its position vector is r center of mass. Now this whole system is made up of different particles. Particle having mass m1, its position vector. Another particle, its mass, its position vector. Another particle, its mass, its position vector. Another particle, its mass, its position vector. So how to remember this equation? This side you have to take particles, and this side you have to write for total object, total system, whole system. That is mass of whole system and position vector of center of mass. Clear? So yes, you have to remember these two cases. Okay, what is equation to find position of center of mass? Clear about this? Yes. These two cases are for particles. Okay. So now for today, yes, this is it.